Hi there. This video is a DAX implementation in Power BI of windowing or analytic functions that are commonly used in data analysis in relational database systems. In relational database systems, we have partitioning over a window that will allow us to find the contribution of every element of a subgroup to the entire group. So what do I mean by this? Let's look at some real life data. Here we have data about flights coming from three major hubs on the East Coast: New York, Boston, and Newark, flying into one destination city, Seattle. For every city, we have carriers that serve a sector. Because of our filtering by city and destination city, we have only 4 carriers involved. The abbreviations are given here. Every sector, by every sector I mean a combination of city and a state, say New York City and Seattle, or Boston to Seattle. The values we are going to aggregate are in this column called arrival delay. In this column, a positive number essentially means that a flight is delayed by those many minutes, 9 in this case. If it is negative, that means the flight is early by that amount of time. And a 0 means that the flight is on time. Now we're going to aggregate this data in 3 ways. One is to find the total number of flights for a combination of 4 columns, that is carrier, city, origin state, and destination city name. For the same combination, we're going to try to conditionally aggregate a count of flights that have been delayed. Why conditional? Because it's going to be based on the value here. If it is positive, only then does it mean that the flight is delayed. So we'll ignore the ones for which the values are negative or 0. So this is the conditional aggregation we are looking for. And finally, we are going to aggregate this data based on a different set of columns, actually a subset of the original set of columns, so that we have a total for every sector. We're going to find out the total number of flights that are delayed per sector, ignoring the carrier. So we're going to find the total number of flights that are delayed from New York to Seattle, Boston to Seattle, and Newark to Seattle. Now we can always group by this data using Power Query's home group by tab. The limitation we are going to face here is that even in the advanced tab, while I can use multiple columns to aggregate the data, I do not have a way of applying an if clause to check if the arrival delay is a positive number, which implies that the flight has been delayed. And so instead of modifying an M query, I'm going to use pandas. To use pandas, we go into the transform tab and run a Python script. This gives me a data frame called dataset. I have the query typed up here, which I'm going to bring into this window. And we look at this query a little more in detail in a Jupyter notebook. This query starts by grouping this dataset by the 4 columns of interest, which is the destination city, origin state, origin city, and carrier. Let's look at the groups created by the pandas group by function. So here, when I group by these 4 columns, pandas creates groups that we can see down here. In every group, it keeps the carrier, city, state, and destination city constant. Whereas in the other group that we see right above, we can see a different combination of carrier, city, state, and destination. Once we have each of these groups, we can perform aggregations on the groups. For instance, using the function count and the aggregation function on the group, we can find the total number of flights, the count of total number of flights for every group. Now we come to our conditional grouping. To do our conditional grouping and store it in this column called count of delayed flights, we apply a lambda function on each of the groups. This lambda function checks for the arrival delay column, and if its value is greater than 0, that row adds to the count of delayed flights for that particular group. And this is how Pandas lambda function within an apply, lambda functions within an apply to every group helps us conditionally aggregate values within a group. Let's run this code within the Power Query. So now when I hit OK, we will get the aggregates that we just coded up. Pandas returned a data frame which we had called final_df. And when I click on this table, I will be able to see the aggregate columns along with the groupings. For every combination of city, state, origin city, and carrier, now we have the total number of flights. We also have the total number of delayed flights, which was our conditional aggregation for the same 4-column combination. Now we have one more task remaining, that is to add up these delayed flights per sector, which means that we ignore the carrier and we add up the values per origin city destination combination. How do we do that? To do that, we need to use a DAX function called ALLEXCEPT that will change the window of our grouping. We will head over to the Power BI main window to the data view. In the data view, we head over to column tools and then new columns to create our aggregation, which is going to be a total of the delayed flights per sector. Let's call this column flights delayed per origin. We will use calculate and we sum up the count of delayed flights. Now we use the ALLEXCEPT functionality in DAX over the table or our query, which is called arrival info. And we only specify those columns for which we want to have the values summed up. That means for the destination city, and origin state, we retain the filters or we keep the filters. Whereas we do not include the unique carrier within that ALLEXCEPT filter list. We are trying to mimic the partitioning that we do in database systems. Now we are trying to partition this data not by the original set of 4 columns, but by a smaller subset of 3 columns. This gives me the total over an entire subgroup. The subgroup was Boston to Seattle. And this is adding up these 3 values here, 9, 15, and 2, because it is ignoring the carrier. And that's happening because in ALLEXCEPT, I do not provide the carrier as one of the filters. The entire data is now filtered only by these columns and not by the unique carrier. Since we are preserving the filters on these columns alone, it is using those as one group, summing up the data in that group for every sector. For Newark to Seattle, for instance, 25 and 27 are added up to 52. And for New York to Seattle sector, we are summing up 42, 8, 25 to give me 75. This final column, which is the aggregation over a subgroup, is very handy in finding out percentage of flights that are delayed per carrier, for instance. We can rank carriers by the delayed number of delayed flights for every month, for instance. And this essentially is mimicking the partitioning over a window that we see in relational databases. Hope you enjoyed this video and that it comes in handy for when you are trying to do an analysis which requires an aggregation over a subgroup. Thanks for watching. Thank you.